Well, hello Internet. So, this week is an interesting one. And before I jump into that, I wanted to give you kind of a download on how I'm pivoting my plan for this, the road less traveled is what it's called. And I will give a brief of what it is and what I'm doing and stuff in a few weeks. But for now, I wanted to let you know that I've taken a step back on this research journey that I'm going on. And I wanted to basically focus more on problem spaces instead of abstract ideas. And over the last, I'd say 9 to 10 weeks, I've been diving in and out of industries and technical topics and just general kind of abstract ideas such as complex systems and things like that. But learning these ideas, these technical topics is easy, or it's not easy, but it's interesting. But it's not as interesting as it would be if it was in the context of a problem that I cared about. And learning within the context of a problem tends to be more sustainable for me and a lot of the people I know. So what I wanted to do is I wanted to take a step back and find a few really big, hairy, audacious problems that really interested me and inspired me and are things that I want to see progress in the future. And I want to dedicate my life, career, and attention to. But I need to find those, and I need to understand which ones strike my interest the most, and also which subsets within those problem spaces interest me the most. So for the time being, the two that have popped up in my head and that I'm going to dive into over the next couple of weeks and months are both climate change and space travel, or space colonization, space stuff in general. So trying to find a problem in there. But this week's about climate change, and I wanted to focus solely on the problem of climate change and what it is. Because we humans, we tend to jump to conclusions quite quickly, or jump to solutions quite quickly, trying to solve a problem without actually understanding the full context of what the problem is. And I'm as guilty as many. I do it all the time. So I had to pull myself back probably 8 to 10 times this week because there's so many interesting solutions and so many interesting technical engineering feats that are happening in a variety of areas for climate change. But basically, I've told myself, no, you need to focus on the problem. You need to understand the problem thoroughly. So I spent a week researching it. I'm sure there's more time I need to spend on certain areas of it, but I have a general idea of what the problem is, or I know more than I did before. And there's a post I wrote. You should go look at it. I'll throw a screencast up here really quick of what it is. In the post, I dive into some of the numbers. I dive into some of the science behind how the planet, the temperature is measured. I dive into some of the timelines that we have, but also some areas that people don't necessarily consider that are both accelerating the rate of the changing climate. So I think it's super interesting, and there's tons of links, tons of videos, books, articles, etc. in there, so you should check it out. But today in this video, I'm not going to regurgitate everything to you, but I'm going to pull out maybe one or two areas I think are interesting. So this week is a intimidating week because it's focused on the problem and the issues with climate change, and it is a big, scary problem. So let's talk about numbers and timelines really quick. So the IPCC, I think, is what the acronym is, and I forgot what the title of the group is, but it's some massive intergovernmental planetary kind of climate change group that focuses on basically studying and summarizing all of the science that's happening all around the planet, around climate, and synthesizing it into a single thing that can be directed towards governments and corporates, telling them what they should or shouldn't do to prevent the climate from getting worse. And historically, they've stated a number of 2 degrees, and now they've basically backed into 1.5 degrees, stating that it's more urgent for us to get to that. So what does this number mean? Basically, in a nutshell, the planet has a set temperature, right? So we have these amazing ability to measure the average temperature of the planet. So after the Industrial Revolution, the planet's temperature has increased rapidly. And it's not just increased, but the concentration of CO2 in the atmosphere has increased drastically as well. And there's a quick graph I'll show here, but it shows the cycles of hundreds of thousands of years of the planet going through these cycles of warming and cooling. But if you look at the concentration of CO2 in the era that we're in, it's drastically spiked over everything else. And what this number is basically saying we need to make sure that we don't increase our average global temperature more than 1.5 degrees over the next X number of years. So it's basically saying after the Industrial Revolution, we can't exceed 1.5 degrees. That's the 1.5 and 2 degrees piece. And there's some timelines as well they've given us. So the timelines that they've given us are for 2030, we need to basically cut our CO2 emissions by half. And that's less than 10 years away, saying that the entire planet needs to cut the amount of CO2 emissions in all the areas that it happens in half in 10 years. That is like, what? And then there's a number of 2050, which basically stating that we need to reduce all of our CO2 emissions all the way down to zero by 2050. And I know that seems like it's far off, 30 years, but it's nowhere near as far as it needs to be. So those are some numbers there. But the most interesting thing about all of this is that this isn't the full story. And I don't know if it's neglected in communication or it's forgotten about or whatever it is, but there's this individual named Saul Griffith or something like that. It's from Australia. I'm gonna show a quick clip here.
We still commit more than enough carbon dioxide to take us over 1.5 degrees and probably up near 2. So that really means we have 0 years. There is no time left.
And in this clip, basically what he's discussing, and I've placed in the article, because this guy is amazing. He has tons of presentations, tons of articles, and I will thoroughly go through all of them because he is just a kick-ass individual. And what he's explaining here is this thing called committed emissions. So within the infrastructure, within the transportation systems and the road networks and everything that we've established on our planet, this is infrastructure we've already committed to creating, or we've already created. And there's this emissions that is going to continue to happen even if we switch off everything today. So if today we stop everything and we go zero to emissions today, there's still these emissions that we've already pre-committed. And when looking at these, and he's studied all the numbers and his group has studied all the numbers, which basically shows that we are already going to exceed 1.5 degrees. We've already committed 110% to this. And the even worse thing is that we're actually going to approach 2 degrees. And there's some studies around this as well that I've linked in the article. So even though they say we have 11 years, we have 10 years to get to half emissions, it's already too late. The clock is already up. So it's basically a matter of we need to do it today, and if we don't do it today, it's just going to get drastically worse in the future, and we're going to get to a 2 to 3 to 4 degree world. And there's tons of horror stories out there of what that means for us, and that's scary. That's terrifying to think that we've already beat the clock. Okay, so if you think it's bad, it gets worse. And the last thing that probably I'll talk about, which is tipping points. And tipping points in the context of climate is basically a domino effect or a cascading scenario, where if one thing happens here, there's a rippling effect where multiple things could happen and it could have a feedback loop in itself. And an example that a lot of people like to reference in climate change are the Arctic and Greenland ice sheets. So these ice sheets are basically melting at a rapid rate, and the reason being is there's more CO2 in the atmosphere, which warms the planet, and they melt faster. But the thing is, as they melt, more ocean is exposed, and if more ocean is exposed, more radiation from the sun is absorbed. So think if it's like a black sheet, it absorbs more heat. If it's a white sheet, it reflects off heat. So if we have more black on the planet, it's going to absorb more heat, which is in turn going to melt the ice sheets even faster. And that's not even the worst part. The worst part is that underneath these ice sheets is this frozen soil, which is called permafrost. And in this frozen soil, there's this stuff sitting there called methane. And methane is it's like 34 times more potent to the atmosphere than CO2 is. So once this methane's released, it's just gonna feed that loop again, and the ice sheets are gonna melt more and more and more. So it's this reciprocal feedback loop. And the worst part is that there's multiple tipping points around the planet. So it's not just the ice sheets, but there's a multitude of areas that tipping points could occur. And I'll show a graph here, which basically shows a cascading effect where if one tipping point happens, another one could get knocked down, and then another one could get knocked down, and then it's just a continual effect of the entire planet just like imploding in on itself. So that is the positive news for this week. We have some numbers, we have some timelines, we have some interesting fun facts. But I guess there is one point around the tipping points which is interesting that I came across as well. There's a Vox article I'll show here which talks about the social tipping points, because tipping points can go both positive and negative. There could be two ways to this. And the positive one for society is that there have previously in historical times been tipping points that have caused benefits to humanity. And there's been a few studies where basically these people have pulled together these social tipping points and said, okay, well, if this has happened in the past, are there ways that we can actually engineer social tipping points within society today to rapidly increase our ability to prevent climate change or to mitigate climate change. So that's the good news there with tipping points. This week has been an interesting one. Like I said, I wanted to focus on the problem. I didn't want to jump to solutions because I know there are tons of interesting solutions, both engineering, socially, economically, culturally, all that stuff. But I wanted to truly understand the context of the issue that we're in. And I will continue to do that. But with that being said, we have dove deep into the problem, or I've dove deep into the problem. I've given you a surface level summary. Go to the article and check it out if you want. If not, that's fine. But yeah, if you're interested, I have a newsletter. Subscribe to it. I will send fun facts and random stuff related and unrelated to what I'm researching. And until next time, we will hopefully find some solutions and interesting ways of combating and adapting. Internet, see you next time.